Hello everybody. So in this video I'm going to be discussing hypothesis testing for the population mean when the population standard deviation is known. So let me go ahead and share my screen and we'll get started. Alright, so here's our first example. So we're going to do some examples where we're given the sample statistics and some examples when we are given data sets. So assume the study states that the high school students eat an average of 2,100 calories a day. However, other researchers believe this number is increased. Assume that other researchers take a sample of 50 students and determine the sample mean calories of those 50 students is 2,200. Assume the population standard deviation is 150 and your significance level is 0.05. Provide the null and alternative hypotheses. So the null states whatever the currently assumed mean is, which is 2,100. And then the researchers believe the number has increased, so the alternative is going to have a greater than sign. And so now let's go to our Rguroo and get the p-value. So we're going to go to Analytics, Analysis, Mean Inference, One Population. I'm going to enter in my sample mean. So my sample mean was 2,200, sample size of 50, population standard deviation 150. So 2,200, sample size of 50, population standard deviation 150. And then here you're going to put whatever the variable name here is. So what's our variable in this problem is calories. You could put anything in this box. I just always put whatever the variable name is because that's what it technically wants, but you could put anything there. You just have to put something there to make it run. And then let's go to test of hypothesis. Our significance level is 0.05. Yep. And then our null, or I'm sorry, alternative is greater than 2,100. And since we know the population standard deviation, we check Z statistic. If we didn't know the population standard deviation, we would check T statistic. Hit the eyeball. And so I get a p-value of 1.21 e negative 6, which I wrote here. So basically the e negative 6 means times 10 to the negative 6. So it means to move the decimal 6 places to the left. So 1, 2, 3, 4, 5, 6. So, and I've said this in class, the E basically also means that if you see the E part, it means your answer is basically 0. It's a really tiny decimal. So our answer is basically 0. So since our p-value is less than the significance level of 0.05, that means we're going to reject the null hypothesis. And then if we reject the null hypothesis, that means we have sufficient evidence to say that the alternative hypothesis is true. So we have sufficient evidence to conclude that the mean number of calories high school students eat is greater than 2,100 calories. So basically writing this alternative hypothesis in sentence form. And then also one other thing I'll point out, the OBSZ stat is the test statistic. Sometimes Newton will ask you for that. All right, let's do another example. Assume a city claims that the mean age of children in the town is 12 years old. However, the residents believe this age should be different. Assume the residents take a sample of 70 children and determine the sample mean age is 12.3 years, and the population standard deviation is 2.5 years. Assume the significance level is 0.01. So my null, so the current claim for the mean is 12 years, so that's going to be my null. They're saying it should be different, so we don't have a direction here. So that means my alternative is going to be not equal to. And so now let's go to our Rguroo and get the p-value. So I'm just going to go under basics and edit it here. So my sample mean in this problem was 12.3. My population standard deviation was 2.5 and my sample size was 70. And then what is our variable here? Looks like I believe it's children's age. Yes. Let me check real quick though that I put that in the notes. As I want to use the same variable name that I used in the notes for consistency. Okay, age of children. All right, so my reshare here. So my variable here is going to be Age of children in years. So I always put whatever the variable name is, and then I put units with it too. But you could put anything there. You could put just an X even. That's just something to make it run. And then test hypothesis, significance level was 0.01. Then my alternative was not equal to 12. So this equal to with an exclamation point is the not equal to sign. And then we're still going to check Z statistic because we still know the population standard deviation. You would check T if you didn't know the population standard deviation. Hit the eyeball. And I get a p-value of 0.315. OBSZ stat would be the test statistic. So there's my p-value. So that p-value is higher than my significance level of 0.01. So that means I'm going to fail to reject the null hypothesis. Now, if I fail to reject the null hypothesis, that means I don't have sufficient evidence to say that the alternative hypothesis is true. So I don't have sufficient evidence to conclude that the mean age of children in the town is different than 12 years old. Basically writing this alternative hypothesis in sentence form. Okay, let's do one more like this and then we'll do some data sets. Assume a realtor claims that the mean price of homes in a neighborhood is $460,000. Assume another realtor believes that this number is too high. He takes a sample of 20 homes, determines the sample mean price is $450,000, and the population standard deviation is 30,000. And then our significance level is 0.1. It's my alternative here. So the current claimed mean is 460,000. That's going to be the null. And then the alternative, so I said it's too high. So that means it's going to be less than for my alternative. Now let's go to our Rguroo and put everything in. Oops, I didn't mean to stop my share there. Let me reshare here real quick. There we go. Okay. So I'm going to go under basics here. And then my sample mean was, I believe, 450,000. Population standard deviation was 30,000. And then my sample size was 20. And the variable in this problem is home price in dollars. Once again, you can put anything in this box. Just make sure you put something or it won't run. My significance level is 0.1. And then my alternative was less than, and it was 460,000. And then I'm still checking Z statistic because I still know the population standard deviation. You would check T if you didn't know the population standard deviation. Hit the eyeball. I get a p-value of 0.068. And then the OBSZ set is my test statistic if you were ever asked for that. So my p-value of 0.068 is less than my significance level of 0.1. So that means I'm going to be rejecting the null hypothesis. And if I reject the null hypothesis, it means I have sufficient evidence to say the alternative is true. So I have sufficient evidence to conclude that the mean price of homes in the neighborhood is less than $460,000. All right, let's do some with data sets now. So assume a study claims the mean weight of dogs in a city is 18 pounds. However, it is believed that the mean weight has changed. Assume the weight of dogs in the city is normally distributed, and the population standard deviation is 2 pounds, and then we have a sample of 15 dogs, and those are their weights. Okay, so let's start with a non-alternative here, and then we'll do everything in our Rguroo. So the current claimed mean is 18, so that's going to be my null. We believe it's changed, so alternative is not equal to. Now let's go to our Rguroo and get the p-value here. So I'm just going to close this out here, open a new one. So in Blackboard, this is going to be under the 9.3.8 downloadable datasets, dog weights. So go ahead and download that. And then you're going to go under data, data import, import dataset. And you're going to choose the file from your downloads folder. And then header on the first line is fine. Mine always have titles in the first line. Just double check on it to make sure there's a title on the first line, because otherwise you would have to select no header, but it should be fine. Hit upload. And there is our data. Now, to do the hypothesis test, we're going to go back to the analytics, analysis, mean inference, one population. I'm going to select my data set this time in the variable. And then my population standard deviation was 2. So I'm going to enter that in for the population standard deviation. Go to test the hypothesis. My significance level was 0.05, I believe. Yep. And then my alternative was not equal to 18. And then I'm checking Z statistic because I know the population standard deviation. Once again, if you didn't know the population standard deviation, you would check T. Hit the eyeball, and I get a p-value of 0.423. And if you ever want to save one of these, you can put a title up here and save it. But you probably shouldn't have to. And then OBS stat is the test statistic. Okay, so my p-value of 0.423 is greater than the significance level of 0.05. So that means I'm going to fail to reject the null hypothesis. And if I fail to reject, that means I don't have sufficient evidence to say that the HA is true or the alternative. So I don't have sufficient evidence to conclude that the mean weight of dogs in the city is not or is different than 18 pounds. So once again, writing the alternative in sentence form. All right, let's do another one. Some police have concluded that the mean car speed in a particular mile on a highway at a particular time of day is 75 miles per hour. However, those driving on the highway believe people drive slower than this. Assume the car speeds are normally distributed and the population standard deviation is 3 miles per hour. A sample of 12 cars is taken and their speeds in miles per hour are the following. And then assume the significance level is 0.1. So my currently assumed mean is 75, so that's going to be the null. And then the claim is that they believe that it's slower than 75, so that's going to be less than for the alternative. So let's go to Rguroo and get the p-value. So I'm going to close all this out here. So I'm going to close this, and I'm going to just delete the old data set too. So you can right click and delete to delete old data sets. And then I'm going to download the car speeds one. So I'm going to go to data, data import, import dataset, choose the file from my downloads folder. For all my datasets, there's going to be a header in the first line. Just double check the ones on Newton to make sure that it's there. Hit upload. All right. And then I'm going to go to analytics, analysis, mean inference, one population, select my dataset and my variable. And my population standard deviation here was 3. Go to test the hypothesis. My significance level is 0.1. And notice also when you select the data set, it fills in the variable here for you. And then my alternative was less than 75. Then I'm going to check Z statistic because I know the population standard deviation. If I didn't know the population standard deviation, then I would check T. Hit the eyeball. So I'm getting a p-value of 4.19 e negative 6, and my test statistic is right here if you were asked for that. So remember that means the e negative 6, that's the same as scientific notation, so it's the same as times 10 to the negative 6, which means to move the decimal 6 places to the left. So counting 6 places to the left gets you this number here, basically 0. Like I said, if you see the e, it basically means your p-value is 0. So since that's less than the significance level of 0.1, that means I'm going to reject the null hypothesis. If I reject the null hypothesis, that means I have sufficient evidence to say the alternative is true. So we have sufficient evidence to conclude that the mean car speed on the particular mile on the highway at the particular time of day is less than 75 miles per hour. So once again, we have sufficient evidence that our alternative is true. So just writing the alternative in sentence form. All right, last example here. The study claims that the mean commute time in a city is 30 minutes. However, it is believed that this is too low. Assume the commute times are normally distributed and the population standard deviation is 10.5. And then we have the sample data right there. And our significance level is 0.01. All right, so the currently assumed mean is 30. And it is believed that this is too low. So the alternative is going to have a greater than sign. So now let's go to Rguroo and put everything in. So let me close all this out again. And then right click and delete to get rid of the data set. Okay. So then I'm going to download the commute times data set off Blackboard. data import, import data set, choose the file from your downloads. And then, like I said, all mine have a title in all my data sets have a title on the first line. Just double check that the Newton data sets do have a title on the first line and hit upload. So then I'm going to go under analytics, analysis, mean inference, one population. I'm going to select my data set and my variable. And then under population standard deviation, that's 10.5. And then I'm going to go under test hypothesis. Significance level I want to say was 0.1. I'll double check that. No, 0.01. And then my alternative was greater than 30. And then check Z. Because we know the population standard deviation. If we didn't know it, we check T. Hit the eyeball. I get a p-value of 0.11 and my test statistics right here if Newton asks you for that. So my p-value is definitely higher than my significance level, so that means I'm going to be failing to reject the null. If I fail to reject, that means I don't have sufficient evidence that my alternative is true. So we don't have sufficient evidence to conclude that the mean commute time in the city is greater than 30 minutes. Basically, that's just the alternative in sentence form. And that is it. So that is hypothesis testing for the population mean when the population standard deviation is known. If you have any questions, please feel free to reach out.